Hello students, we are going to take up the oxidation number. Right. Now what do you understand by the term oxidation number? It is a real or imaginary charge which is there on the atom when the atom is in combination state. Now children, what is valency? It is the combining capacity. Now just giving you examples, suppose I am having two hands. Okay, so this is my valency. This is my combining capacity. But suppose when I am doing some work and I am just using one hand, so this becomes my oxidation state. That is, this is the real or imaginary charge or which I am going to use when I am there in the combination state. Is this clear? Now, whenever there is an oxidation number, okay, or a state, they both mean same. So whenever there is a compound like electrovalent compound or a covalent compound, then we decide the oxidation number on the basis of the charge. Okay, so let's understand. Right. So when the compound is electrovalent compound, so electrovalent bond is formed by the transfer of electrons. So there are anions and cations. So whatever charge is there on the anion or is there on the cation, that becomes the oxidation state or oxidation number of that element. For example, in sodium chloride, sodium has got one positive charge and chloride has one minus charge. So this minus 1 is the oxidation number for chloride and plus 1 is the oxidation number for sodium. Likewise, if I take calcium chloride, okay, so over here calcium is having plus 2 charge and chloride is having minus 1 charge. So oxidation number for chloride will be minus 1 and oxidation number for calcium would be plus 2. Okay, now when we talk about the covalent compounds. So in covalent compounds, the oxidation number is derived by assigning electrons. So how do we derive? We derive by assigning electrons to the each bond. Okay, and we see which one is more electronegative. Okay, so let's take example of HCl. Let's take example of HCl. So in HCl, you see the bond is the single bond is there and the bond is shifted towards chloride. Okay, so there is minus 1 charge developed on chloride and there is no electron or you get just one positive charge on hydrogen. So this is the oxidation number. Now, when we talk about chlorine, so chlorine there is, both are identical on both the sides, right? Chlorine here and chlorine over here. So the shared pair remains as such because both have got same electronegativity. Hence, in this state, the oxidation number is 0. Is this clear? Now, let's take an example, right? Now, before understanding the example, we need to understand the table. This table, children, I have compiled this table, okay, so that on one page only you have all the values and you are able to learn, and when you are practicing, it will be easy for you, okay. So the first column is the species. So if there are free elements, the oxidation number is 0. For fluorine, it is minus 1. For oxygen, it is minus 2. But oxygen in peroxide is minus 1. It is in superoxide state in minus half. Right? In OF2, it is plus 2. And O2F2, it is plus 1. So remember, oxygen is not same in all. Right. Now, when we talk about anion and cation, anion and cation have their electrical charges like we discussed earlier. Neutral molecules have got 0 oxidation number. Right. Now, when we talk about groups, so as the group is there, accordingly the oxidation number is there. So, if it is group 1, oxidation number is plus 1. If it is group 2, oxidation number is plus 2. If it is group 3, oxidation number is plus 3. Or group 13 is there, oxidation number is plus 3. Then group 14 is there, oxidation number is plus 4 minus 4. Likewise, group 15 it is plus 5 minus 3. Group 16 it is plus 6 minus 2. Group 17 it is plus 7 minus 1. Group 18 it is 0. Is this clear? And when we have to calculate for carbon, right, in organic compounds, So we calculate the oxidation number of carbon by taking out the number of oxygen, multiplying it by 2. We subtract the number of hydrogen and we divide by number of carbon. Okay, so let's take some examples. Now, the question is you have to find out the oxidation state of manganese in KMnO4 and chromium in potassium dichromate. Okay, so we consider them as X. So over here, this is M is X, right? So I have written, right, I'll solve it so that it becomes easier. I've written X so that it is easier. Okay, now look here. Potassium, belongs to group 1, so it has got +1 oxidation state. Manganese, we have to find out, so this is X plus oxygen, how many? 4, and what is the oxidation state? It is -2, and when the compound is there in free state, it has got a 0 charge. Okay, so this will be what? +1 plus X minus 8 is equal to 0, or X is how much? 7. Is this clear? So the charge or the oxidation number or oxidation state on manganese is +7. Likewise, we can find out for potassium dichromate. So potassium 2, right, into +1 plus 2x, because 2 chromium are here, then plus 7 into -2 is equal to 0. So 2 plus 2x minus 14 is equal to 0, or 2x minus 12 is equal to 0, or x is equal to +6. Is this clear? Similarly, we can find out the oxidation number of ferro, iron. Okay, in this potassium ferrocyanide and potassium ferricyanide. So the formula is K4FeCN whole 6. In this, you have to find out the oxidation state of iron. Over here in K3FeCN6, again you have to find out the oxidation number of iron. Over here for sulfur, and again for sulfur. Now, when such is the case, Cn you have to take it as whole. So Cn has got -1. Okay, so this will be what? 4, 4, right? Potassium is 4 into +1, right? Then plus you have got X plus how many cyanides are there? 6, and each is having how much charge? -1 is equal to 0. So 4 plus X minus 6 is equal to 0, or X is equal to 2. Right, so this is what? Iron in +2 state. Likewise, we can calculate for K3FeCN whole 6. Over here, this will become what? 3 plus X plus 6 minus 1 is equal to 0. So when you solve, X will become 3. Okay, so this is ferric. Now we talk about sulfate. So if we talk about sulfate, it is X plus 4 into -2 is equal to -2. Now from where does this -2 come from? Because of this charge, right? So this is how much? -8. -8 will go this side, so you will get what? X is equal to +6, right? Now again over here Na2S4O6. Now this is 2 plus how many sulfurs are there? 4, and here you have to calculate. So this is X plus oxygen is how much? -2. So this is X, this is 6 minus 2 is equal to 0, or you will say what? 2 plus 4x minus 12 is equal to 0, or this is what? X is equal to 5 by 2. So this is what? In fraction. Now have you understood that most of the cases you have find what? The oxidation number in plus state or in a whole number state, right? But over here it is in fraction. So why it is in fraction? That means the molecule is having the atoms, and these atoms are linked with each other. So we have taken out the average. Okay, so there is a procedure also how to calculate, and we calculate through chemical bond method. This we'll discuss in the next video. Okay, likewise, if suppose we have to calculate for oxidation number for manganese in MnO2. So again, simple now. What you have to do is take this as X plus 2 minus 1, because how many are there? There are two oxygens, and each oxygen has got minus 2 charge is equal to 0. So X plus this is minus 4 is equal to 0, or this is, X is equal to 4. So manganese is in plus 4 state. Over here, 2x plus 3 into minus 2 is equal to 0, or 2x, this is how much, plus 6 is equal to 0, not 6, it is minus 6, because plus into minus, so this will be minus and you'll get x is equal to 3. So this is how you can calculate the oxidation number. Now we move on to the last one, how to calculate the oxidation number of carbon in organic compounds, the compounds containing carbon, hydrogen and oxygen. So what is the formula? We take the number of oxygen, multiply them by 2, then we subtract the number of hydrogen and divide the entire thing by number of carbon atoms. So let's take example of HCOOH. So over here the oxidation number of carbon is, what is the number of oxygen? 2. Right, so we multiply by 2. Number of hydrogens are how much? 1 plus 1. So it is 2, and we divide number of carbon is 1. So this is how much? 2 2s are 4. 4 minus 2 is how much? 2 by 1. So in this, the oxidation state is plus 2. Let's take for ethyl alcohol, right? So over here, how many oxygens are there? 1 oxygen into 2 minus how many hydrogens are there? 5 plus 1, 6. 6 divided by how many carbon? 2. So this will be minus, right, 4 by 2. So minus 4 by 2, that means it is minus 2. So this is how we can calculate the oxidation number. So some examples I have taken. Now you have to take up some more practice, and I'm sure you're going to come up with like that. Thank you.